Welcome to yet another episode of Quest, the inter-school science quiz brought to you by the National Council of Science Museums and 𝐿 Kendra, Kolkata. As you know, the emphasis behind our quiz is to provide education rather than a competition. Today we have two new schools for you. Before introducing them, let me ask you to give a big applause and welcome Mr. G.S. Rautela. Mr. Rautela is the director of Nehru Science Centre, Mumbai, and he'll be conducting a lot of very interesting experiments. Introducing the teams to you, on my right is the J.C. Bose team, the girls from G.D. Birla Centre for Education, and you are?
Ishita Chakravarti from G.D. Birla Centre for Education.
Sudeshna Mitra.
Suranjana Rangarajan.
And have you been watching Quest on the television?
Sure, sir.
Yes.
Have you been enjoying it?
Very much.
Do you find our questions too difficult or too easy?
Sometimes they are difficult,
Mixed.
but
Sometimes they're difficult. Okay, we'll find out what happens today. And on my left is BD Memorial School, C.V. Raman team. You are?
Hello, I am Tathagata Sengupta from BD Memorial Institute.
I am Arnab Gupta. I am Apratim Biswas.
The rules fairly simple. The direct questions carry 20 points each, plus 20 if you get them right. At the end of 15 seconds, they go to the other team. That's for 10 points. If they do not have an answer, we'll go into the audience. In the buzzer rounds, plus 20 and minus 10. More about it when we come to it. The very first question is for the J.C. Bose team. Mr. Rautela. And now on to the very first question, which is for the J.C. Bose team.
Well, your question is, I have two bottles connected by a connector, and the connector has a hole. But when I put it down, you will see that water stops falling after some time. All right? Now the question is, what will you do, one single action by which you can make the whole water drain out to the bottom bottle? One single action by which you can make the water to drain out to the bottom bottle. And why? Of course.
Looks quite a bit like an hourglass, you know. Come on, girls. You must hurry up, 5 seconds to go. I'm afraid they do not have an answer. Yes?
We have to close that hole because when we invert this system, then the air enters from the hole and it exerts some pressure upwards to the liquid, which prevents it from coming down. But if we close the hole, then due to the gravitational attraction, the fluid will come down.
Well, first of all, the hole is needed for the water to go down, otherwise how does it go?
Should we go into the audience, Mr.
Yes,
Rautela?
would you, anybody in the audience?
Well, we have our old friend Wasim coming here. Hello, Wasim. Yep.
If you cool this lower bottle, the air will be compressed inside, and the pressure will be the air will be compressed inside, and the pressure will be less, and hence the water from the upper bottle will come to less.
Well, these are various answers that science offers. This is called scientific inquisitiveness. I think each solution what they are giving could be right. Making a hole is also right. Cooling the lower bottle is also right. It could happen. But as I said, I don't have any other material to do anything to these bottles except my two hands.
May I say something?
Yeah, okay, I'm going to do it, so you can go to your seat. I'm going to perform a small action for you and see whether it happens. All right?
Wow, looks like a whirlpool, Mr. Rautela.
Yes, you're right. I produce a whirlpool inside this bottle, and you know whirlpool is formed when the liquid column or the fluid column is rotated, the molecules fly away because of centrifugal force. At the center there is a low pressure, and that low pressure means no molecules. There is a gap, the air from bottom comes up to allow the liquid to fall down. Otherwise, why the liquid was not going down? Because there are no passage for the air to escape from the bottom bottle. The hole was almost one of the answers, but I didn't want to do any damage to the bottles. So you got it? Yeah.
Mr. Rautala, I've got a question for you here.
Yeah.
In the whirlpools that we see in rivers or in any water body, is there also air being sucked in at that time?
Yes, in fact, yes, it is. You must have seen the dust flows into that whirlpool. It's because of the low pressure at the center of the whirlpool.
Pretty much like a tornado?
Yes, it's tornado and whirlpool has almost similar principle.
Okay. No score then to either team, and we move on to the second question of today's episode of Quest. With the scores reading love all, that's no score to either team. CV Raman team, here's your question.
Well, I have a spool which I have wrapped around this a ribbon, all right? And I put it on the table like this. I take enough of the ribbon in my hand. Now, what I do is when I pull the ribbon at the bottom level, this bobbin comes towards me. You see once again for you? When I pull it at the almost horizontal level, it comes towards me. But when I pull it a little up, it goes away. The question is, why does the bobbin comes towards me when the angle of pull is less? Why it goes away when the angle of pull is higher?
You must hurry up, your time's up. I'm afraid we have to go to the other team. Yes,
Would you
girls?
try?
Trying? Not trying, don't have an answer. Audience?
I may be wrong.
Where do you come behind? Come this side.
When we are applying a force, and when theta is the angle, it makes with the horizontal. It's low. We are applying a force T, suppose that. Let that be T along the thread. Therefore, the horizontal component of the force, T cos theta, since cos theta is theta is less than 45 degree, therefore cos theta is more, therefore the force is greater, and when we are applying that at an angle greater than 45 degree, the force is lesser. Therefore, the torque produced in the first case, that's bringing it towards this case, and the torque produced that's sending the ball.
Well, you're well attempt, but let me give you a correct explanation of this. See, when I was pulling it at, you can go to your seat. When I was pulling it at lower angle, so let me first of all tell you what are the three conditions to this. Number one, a force in the direction of the pull, and a reaction of this where it is touching on the ground, because try to oppose that force. And these two forces, if they are not in same direction, they will form a torque, all right? So at a particular angle, it might even rotate at its own position. That is the balanced position of the frictional force and the force of pull. But when I am pulling at a lower angle, what is happening? The torque produced is clockwise. So it rotates towards it. When I am pulling at high angle, the torque produces the other side. So it depends where does the direction of the force is, the point of equilibrium, behind that or in front of that, right? If it is in front, it will come towards you, it's behind, it go away from you, all right? That's the correct explanation.
Sorry, Mr. Rautala, does that explain why when we see a cricket match, the people on the ground staff, they pull a roller rather than push
Well,
it?
I think very close similarity, but I won't say exactly this rotation, but that's why pulling a roller is much easier than pushing a roller. You see in the cricket ground or you see on the roadside sometime, a cart is always pulled, never pushed, because that gives it a mechanical advantage.
Right then, no score to either team, and we move on to the third question of today's episode. Both teams yet to get off the mark. The next question, the third question, is for the JC Bose team.
Well, the question is, you have been given a paper which is cut into 3 pieces, not 3 parts, but they are not separated from each other. Open it up and hold it like this. All right? When you pull from both hands, how many pieces it will make? Any guesses? The question is not that.
2 pieces.
2 pieces? How many pieces? If you pull it both hands, how many pieces will break into? 2, and you?
2.
Okay, that part of the question is, how can you now make it to separate in 3 parts?
Pull it from both.
What can you do to this to make it? All right, okay, that's all right. I'll do it for you. I'm not breaking my. How will you be able to pull it in such a way that it has 3 parts? What can I do? Yes, that's one answer. The question is for them, right?
Yes, it's
Yeah.
JC Bose team.
How can you make it separate in 3 parts?
You must hurry up, girls. We are running out of time here. Not trying. Okay. CV Raman team.
Would you try?
I showed it, no?
No, you have to give an explanation.
Yeah, why? Now the question is,
Why?
you are by holding it with your teeth, you are able to separate in 3 parts. Why was it possible?
Okay. Initially, when the force is applied from the 2 corners, somehow the force gets concentrated at one of the 2 markings, so it separates from there. Whereas when I'm holding it from my teeth, when I'm providing some other point of support, the center piece is unable to move away. So when I'm pulling the side, the 2 pieces away, both have to move away, so they break from the 2 pieces.
Okay. We give them 10 bonus points for this question. But let me add to this answer. When there were 3 pieces, it was in 3 parts. When I was pulling it, or you pulled it, it was always 2 parts. Why? Because the middle paper being very thin, the force which you applied, the acceleration that it gave to quickly got transmitted even to the middle piece. As a result, you are not able to apply a force at one point. But by holding this, you could stop that acceleration passing, and he stopped it. It didn't go to other side, and he could pull it. But I have another solution for this. I put a heavy load at the central piece. And see, I got into 3 pieces. All right? So because the acceleration did not pass up because of the heavy mass, because the acceleration which applied on the small piece of paper was smaller, which could not accelerate this portion because of the heavy mass, that's why it got separated into 3 parts. All right? Thank you very much.
Well done, CV Raman team. You pick up 10 points, and we go into what's going to be your next direct question, which is the 4th question in today's episode of Quest. The CV Raman team is on 10 points, JC Bose yet to score. You're watching Quest, the Inter-School Science Quiz brought to you by the National Council of Science Museums and 𝐿 Kendra, Kolkata. The next question is for the CV Raman team.
Well, I have a table tennis ball and a cup, and I put little bit of water, say it is half filled, and I put this table tennis ball, of course it's going to float on this, but when it floats, it always goes to the side. No matter what I do, I bring it to the bottom, to the center, again it goes to the end. It goes. Now what should I do to make it balance at the center, or bring it to the equilibrium at the center of this?
If you if you pour water up to the brim, then it will always tend to flow towards the center.
Okay, let's do that. Then you give me explanation. Why does it happen?
To the brim.
He was almost right. Now tell me what is the explanation? Why does it at the bottom, when water was less, it goes to the rim, and when water is more, it is at the center?
Actually, when there was less water, then but when there is more water, then the central part of that surface, it's at a higher level, because due to this is due to the surface tension. But
why it is at higher level? The meniscus, you mean, is concave or convex?
The
No,
meniscus is convex.
meniscus is
In case of water, is always concave.
concave meniscus.
Okay, yeah.
Yeah, concave meniscus.
Now, would you try?
Since water has a concave meniscus, when
Yeah.
it is half filled,
Yeah.
so the ball tends to move towards the rims.
Why? That's what the question is.
Because
the tension.
No. Would you try?
Please
Yes,
cos
yes.
theta t sin theta.
Please come.
Wait a minute.
Hold the mic. Go behind there.
We know that the attraction between two molecules of water is lesser than the attraction between a water molecule and that a molecule of the wall. That is why we have a concave surface of water when it is half filled. Because of this reason, when we place a ball at the center, the sides attract it more. So even if the ball encounters little disturbances, when it moves a little bit to one side, the attraction by that side takes over and the ball moves to that side. But in case of when we have filled it to the brim, we have forced the water surface to become convex. That is why as the ball is little above the level of the brim, the walls cannot exert so much tension on the surface. So the ball does not have a tendency to go to the side and it remains at the center if you place it at the center.
You are absolutely right. I would add to this answer a little bit. When the meniscus was convex, the force was towards the center to reduce the size of the meniscus. And therefore, the equilibrium comes on the center of the meniscus. As a result, this ball can stay at the center, or rather it can stay a little around the center. I would say that. So that was the correct answer.
Well done. What's your name?
My name is Shayan Chakraborty. I am from South Point High School.
Shayan, please come here. Well done. We have a small memento for you from Quest.
Thank you.
Thank you. You can go back. Anything further to add to that, Mr. Rotela?
Well, there is a surface tension which plays a very important role between a fluid and a solid. And the surface tension, as you know, is very useful to us while washing clothes. The dust particle gets cleansed to the shrinking surface because of the force, and the cloth gets cleaned. So this is a phenomenon which is used in our day-to-day lives.
Thank you. Well, that brings us to the end of the direct questions. The next question will be on the buzzer. Scores at this stage: 10 points to the C.V. Raman team. J.C. Bose yet to get off the mark. Come on, teams, you can do better than that. We've got 3 questions now which are on the buzzer. As you know, plus 20 if you get it right, minus 10 if you get it wrong. These questions will not pass to your counterpart team. They'll go straight into the audience. So when you hit that buzzer, be ready with an answer. Mr. Rotela.
Well, the experiment is, here I have barium hydroxide in this, crystals, which is crystalline barium hydroxide, and I add little bit of ammonium chloride, NH4Cl. Well, and then I shake this. If I am shaking this, it becomes very cool. Touch it. You can touch this. This is very cool. And in fact, even frost is formed around this. Now the question is,
See, they've already hit the buzzer, Mr. Rotela.
okay,
I guess they should give us an answer.
so the question is, why does it cool down?
Yeah, when we take this mixture of barium hydroxide and ammonium chloride and apply some mechanical force when we are shaking it, then a reaction occurs in between them, and we get ammonium hydroxide and barium chloride. This ammonium hydroxide is highly volatile thing, and the ammonia present evaporates out. And in doing this, it takes up the heat from the surroundings, and this cools this thing.
What is this reaction called as?
This is endothermic reaction.
Yes, that's what exactly the answer I'm looking for. So they get 20 points. So you see, this is an endothermic reaction. The temperature in this reaction can go down to minus 30 degrees Celsius. And you see that's how even we are able to get frost, so it is already below 0. All right?
May I?
Yes. Yeah.
Wow, it's really cold.
Yes, really cold.
Right. I think JC Bose team, you are quite cool as far as the scores go. You're yet to get off the mark. The boys from the CV Raman team pick up another 20 points, moving on to 30. And the next question is again on the buzzer. Scores at this stage, 30 points to the CV Raman team, that's the boys from BD Memorial Institute. And the girls from GD Birla Center, that's the JC Bose team, yet to get off the mark. Girls, you can still do it if you hit the buzzer twice successively in the right manner. You must have the right answers. Next question.
Well, the next question of the buzzer round is, I have 3 discs on this vertical shaft, and if I take them up, they all fall down. And the question is, if I take 2 discs, or even 1 disc for that matter, let me start with the 2, and I rotate it. Okay.
Well, the boy is going for the buzzer yet again. You have an answer? Arnab?
Yeah, when we are simply leaving it, it falls obviously normally, but when we are rotating it, it gets an angular velocity. Angular velocity being a vector quantity, it has a direction, and the direction is perpendicular to the direction of motion. Because of this, it tends to go upwards, but the 2 forces balance and the same.
Was
That's
that
not the correct answer?
So it would be angular momentum, which is
My question was different.
Okay.
The torque that acts, acting due to this angular velocity on this angular acceleration on this this torque acts upwards, and this torque balances the force due to the gravity.
So is it angular momentum which acts upwards?
Gentlemen, I'm afraid you're not going to be asked the right question any longer. -10 to you.
Audience.
Any takers in the audience?
Hello, I'm Devadipshan from South Point High School. I'd like to modify what they said. Because of producing the torque, it's not angular momentum or angular velocity as they said, but it is a torque that is acting upwards, and it's balancing the quite.
Well, I think this is the quiz master's question. Mr. Rautela, I guess you'll have to give us the explanation.
Well, when I'm rotating, what exactly I'm doing, the speed is enough, centrifugal force tries to take away the disc from the central point. All right? As a result, it is touching the rod every time, and there is a friction between rod and the disc. It stops it coming down. As the speed reduces, the it falls down. Otherwise, you won't answer your question why the speed reduces and then it falls. Okay? So you follow, when I am rotating these discs, so centrifugal force tries to take away the disc from the center, and it touches the rod every time it tries to fly away. And as a friction is there between rod and the disc, inner circle of the disc, it stops it, it reduces speed. As speed reduces, it starts falling down. But there was an interesting principle here, why this upper disc goes up was nothing to do with science. It was unsymmetrical. This is unsymmetrical, but the bottom 2 discs, it doesn't happen. The gap, why there is a gap between, the answer was correct, that it drives away the air in between. So there is a partial vacuum. The air from outside pushes in and try to create an air cushion in between. That's why they remain separated from each other. All right? So that was the correct answer I was expecting.
Well, no score to either team there. And we move on to what's going to be the last question of today's episode of Quest.
Well, you look at this particular setup, there is a block, heavy block, hung from top and a bottom thread attached to this. Now I'll do two actions. When I pull this gently and when I pull rapidly, what is going to happen?
Well, boy is
Yes.
going for it again. Yes.
When the thread is pulled slowly, the block and the upper string will move down slowly. When a rapid jerk is given, the upper string will snap.
In rapid, the upper string. No, you are wrong. It is going to.
Sorry, the lower
Minus
string,
10.
the lower string will snap.
So, yeah.
The lower string will snap.
But
I'll
I think
give the
there is no
reason then.
scope here for correction of the answer. Once the answer
We can give
given,
the reason. We can give
Yeah,
the
I can give the reason.
that's okay. I think we'll pass on to the audience this question.
Yes, anyone in the audience? We have only one. Yes, Shayan, come again.
This block has a certain mass. As a result, it has inertia. When we pull it gently, the force is, the time given is sufficient to overcome the inertia of this block to get it in motion. But however, and pull the upper string also. But when we give it a rapid jerk, the time is very less. As a result, this block, because it has a greater mass than the strings, it stays in its position and does not accelerate. Because it accelerates, but its acceleration is very less than the strings. As a result, the force on these strings becomes double the force we give. That is the force we give and the reaction from the block.
Okay.
As a result, the lower string snaps, while the upper string endures only the mg of this block and does not have to bear that T we apply.
You're absolutely right. Well, let us perform what he said. Let's do this. I am pulling it gently. It broke from the top. Okay? All right. So what he said was right. When I pull it gently, it broke from the top. When I pull it rapidly, it broke from the bottom. And the answer what he gave was right. I have nothing else to add to his answer.
The final score tally, not a very good one. 10 points to the C.V. Raman team, and J.C. Bose team could not get off the mark. All the same, we thank both teams for coming and being part of our show. And as always, we give a memento from Quest. Well done, boys. And a big round of applause for them, please. Girls, don't look so disappointed. Here's yours and yours. We hope you enjoyed watching our quiz show today. We'll be back again next week with 2 new schools. Please write back to us with your comments to Quest, care of Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week. Till then, it's goodbye.